Well, welcome to today's lesson. We're going to be talking about synthesis reactions today. And so I'm going to go ahead and get started on that. What a synthesis reaction is, basically we're going to take two or more things and we are going to put them together to make one thing. So some of the things that we're going to do are elements with elements, elements with compounds, compounds with compounds. But the key is, and how you'll recognize it, is you'll have more than one thing over on this side, and it always makes just one thing. Okay, so it synthesizes or combines it, puts it together. Okay, makes it. So I'm going to give you some general rules to try to help you out a little bit on how you recognize the different types of synthesis reaction, and then we'll go look at some of them. So before we get started, though, I want to remind you that on the periodic table that we have the metals that are on this side and the non-metals that are on this side. And then again, remember, we've got the zigzag line where the metalloids are at. So as we talk about this, we're going to be talking about metals and non-metals as far as how the different synthesis reactions take place. So these are going to be the general rules. And there are 5 of them that we're going to look at. Okay, so the first one is if I take a metal and I add it to or combine it to a non-metal. Okay, and so when I do that, you are just going to use your regular writing of compounds rules. So here's an example of that, and it might be if you have just our general sodium and I want to add it to chlorine, and so it's just going to go together. You're going to take both elements, sodium, chlorine, put them over here, and then all you have to do is check their charges to see if you need any subscripts. So I'm going to grab me a different color marker here. So we have sodium that is a +1. We've got chlorine that is a -1. And so we don't need any subscripts. Now, I forgot to say before I got started here, if you don't have your yellow sheet and your periodic table out in front of you, you need to pause it and do that, because you are going to be referring to those as we go through the whole time. So again, +1, -1, I need no subscripts. That is my answer. Another example might be if I had magnesium, piece of magnesium ribbon maybe, and I added it to chlorine. Then again, what I'm going to do is I'm just going to bring over my magnesium, my chlorine. I'm going to check my charges. Again, this time, magnesium is a +2, chlorine's a -1. So my actual formula would be MgCl2. Okay? So that is a metal with a non-metal. And again, I'm looking at my different sides of the table, because chlorine's over here, sodium is over here, magnesium's over here. Second one, okay, is as if I have a metal plus oxygen. And what this is going to form is what we call a metallic oxide. Oh, X, that's supposed to be an I. I-D-E, sorry. O-X-I-D-E, oxide. Okay, so what we're going to have is a metal basically with an oxygen. Metal and an oxygen. And so an example of that might be, again, a metal. So I'm going to go ahead and just use sodium again. And this time I'm combining it with oxygen. I remember oxygen is my diatomic. It's a gas. And again, when I come over to here, I'm going to just have the Na and the O. See, that doesn't change. I'm going to check my charges again. So sodium has a +1, oxygen's a -2, and I didn't leave enough room there, but it would be Na2O. I'm going to use magnesium again, combine with oxygen. And again, I'm going to bring my magnesium over, I'm going to bring my oxygen over, and I'm going to check my charges. So look at your periodic table. Magnesium's a +2, oxygen's a -2, so I don't need any subscripts on there. So I'm done. Now, I might back up and say, now remember, these numbers are really not supposed to be written up above there. It should just be MgO and Na2O. And up here, so same as that. Okay, but we're just checking it. So you could always erase them off or whatever. But I don't ever think it hurts to kind of put them up there just to make sure. But this is not, again, the ion. We're just checking the charges to see what our compound is. Okay? And really, there's no difference in these two, right? Because I still just took the element and the element over, and then I balanced my charges. So even though I said they're two different ones, it's really the same thing that's happening. This one, if I have a nonmetal and I add it to an oxygen, okay, in this case, it's going to make a non-metallic oxide. But it's still an oxide, okay? And oxides simply are anything that just ends in oxygen, okay? That's what an oxide is. It just ends in oxygen. So give you an example here. Now, an example on this case of a nonmetal, so that means I've got to pick both of my oxygens a nonmetal too. So it might be a nonmetal, like carbon, and a metal, and another nonmetal, which would be oxygen. And again, it's going to form, in this case, CO2. Now, we do have to be careful because carbon and oxygen could also form CO, carbon monoxide, but we go with what it typically forms, which is carbon dioxide, which would be a gas. Okay, so we do kind of go with the most common unless they tell us something different. Okay, so again, it's still pretty much the same thing. Another example might be hydrogen gas with oxygen gas, okay, and that in this case would form water. Okay, so again, that would be the most common there. So again, as you see, it's about the same. Now these up here, guys, let me come back up to the top here. These are ionic compounds. We're just reviewing that because remember, ionic is a metal and a nonmetal. Okay, this one now is a covalent because it is a nonmetal and a nonmetal. Okay, so I'm not sure why my thing here has got so big, but we'll go with it that way. Okay, sorry about that. I'm not sure what's going on. I've been having trouble with my computer. Number 4. This one now, we're taking a metal oxide, okay? So we're taking one of these answers that we got up here, and we're adding it to water, okay? And what we're going to get here is what's called a metallic, or metal, either way, hydroxide. And if you'll remember, hydroxide is OH, okay? OH with a -1. So we're going to be taking something like we have up here. So maybe I've got MgO, okay, my metal oxide from up here, and I'm adding it to water. And what it forms is a metallic hydroxide. So the metallic piece of it, that's going to be your magnesium. And your hydroxide is just OH. Okay, now again, I got to check my charges, because this one's going to be ionic again. So I've got a negative, let's see, +2 is magnesium. Sorry, my brain farted there for a second. And a -1 here. Okay, so I'm going to need 2 of these. Let's go ahead and just take that Na2O that I had up there, that I formed, again with water. So even though there is a subscript 2 here, I don't bring that over. I'm just doing Na, and then it's going to have an OH with it. And I'm just going to check my charges. So Na is a -1, OH is a -1. Sorry, that's a +1, -1. So I do not need, again, any subscripts. Okay, so anytime an oxide with a water, it's going to form your metallic hydroxide. You're just going to take the metal and you're going to take the OH as a hydroxide. Okay, number 5. This one is the toughest one, but it's also the one we do not see near as often. And it is a non-metal oxide added to water. Okay, and it forms what we call an oxyacid. Oxyacid means an acid that contains oxygen. That's all it is. Okay, that's what an oxyacid is. Sorry, let me clean things up here for you a little bit. Get me out of the way. Okay, so that's what a oxyacid is. So when we go to form this one, an example here would be if I take a nonmetal, so that would be SO3, on nonmetal with an oxygen. I add water to it, and in this case, the hydrogen, since it's an oxyacid, since it's an acid, remember we talked about acids start with an H, and then the oxygen here is going to come over to here, and I'm going to get SO4. And then if I go check my charges, SO4 is a -2, hydrogen is a plus, so I need 2 hydrogens. And so we do get sulfuric acid out of that. Okay, and again, this is probably the least in terms of examples that we do. So let me see if I can spread this out a little. Okay, I'm not sure why I can't get that to zoom out a little bit, but again, those are your basic and your general rules for a synthesis. So be sure you have all of those written down as you need to, and then we're going to go to your worksheet and look at some examples.